throughout the 2000s and the early teens, there was this underlying assumption, sort of the null hypothesis, that humans sleep exactly like we would predict humans would sleep, given our phylogenetic placement, given our evolutionary history, etc. There's no real difference from other primates. And the research that I did alongside Charles Nunn at Duke University when we were teaming up together uncovered, in fact, humans are absolutely bizarre. When you compare us as a single lineage compared to other primates, humans are fundamentally unique in that we have significantly less total sleep time. So we are the shortest sleeping primate of any primate on the planet. If you average us around 7 hours, which if you take that cross-culturally, you try and get a really representative sample, about 7 is a good human average. Compare that to, say, a owl monkey that sleeps 17 hours out of the day, right? Like, those are the marathon sleepers of the primate order. The average is about 11 and 11 and a half. And what you would predict, given the models that we did that accounted for evolutionary history and brain size, body size, diet, the models predict that humans would sleep 10 and a half hours out of the day, but we sleep 7. And here's the kicker: we have the highest proportion of REM out of any primate on the planet. So what that means is that there was something unique that occurred throughout human evolutionary history when we diverged from Australopithecine ancestors and chimpanzee common ancestors 6 million years to about 2.5 million years ago. There's a significant divergence in our sleep compared to our primate cousins. Humans, there's always something better to do with your time than sleep, right? There's a cost to sleep. You're not doing these really fitness critical functions, right? You're not seeking calories, you're not seeking a mate, you're vulnerable to your environment. And with humans, we doubled down on this vulnerability because we have more REM, and when you're in REM, your arousal threshold is actually higher. When you have slow wave sleep, your arousal threshold is higher, meaning that if somebody in your environment says your name or there's a stimulus in your environment, you're dead to the world, right? In these, and we have biased these. And the idea functionally likely is that it's some link with our ability to consolidate emotional memories, our ability to consolidate the activities that we do in the day, memory consolidation, and we have links with creativity and innovation with REM sleep in particular. And then of course there's this really dynamic hypothesis about threat simulation theory. That's an evolutionary hypothesis about the function of dreams. And so the idea here is that we engage in dreams as a type of simulation of potential threats we might face in the awake world. So it's like just a model, a rehearsal model of potential threats. And what you see that, in fact, when you do dream studies, as part of my lab, we actually have a student that's doing this. When you record daytime activity and people record what they were doing in the day, and then you actually record their dream content, they'll wake up and they'll record their dreams. They're dreaming about stuff that's really different. Like, they're dreaming about social problems. They're dreaming about fears, anxieties. They're not dreaming about, being in front of a computer 8 or 10 hours out of the day. So all that combined means that likely in human evolution, we favored this really deep, high quality sleep. And one of the exciting things from a social perspective of why this is cool with respect to human evolution is that we likely did this because we were a social species. So it's sort of counterintuitive. We tend to think that if we're with a lot of people, our sleep's going to reduce, right? We try and isolate ourselves in these little protective chambers where we minimize all this, stimulus, and especially we try and sleep alone. We go to great lengths to do this so we can get a good night's sleep. And it appears as though the initial evolutionary move was to, when you're in a camp, right, in a band-like structure, which likely our forebears some 1.8 million years ago were like, you have almost like a protective social shell where you can sleep, you can take a nap during the day, you can sleep securely at night, and even though there's noise around, that's way better than a predator eating you in the middle of the night. So that's sort of the idea. That's the narrative, the evolutionary narrative there.